Hi everyone, this video is going to help you with the big ideas 10.4, what Mr. Egler called the 10.4a end of section exercises. I'm going to give you some tips and some hints, and hopefully this is helpful. So number 1 says, what is the sample space of an event? How can you find the sample space of 2 or more events? So if you rewatch Mr. Egler's video, or if you go to page 422 of your textbook, it will tell you the answer to this one. I will tell you that it's not a number, it's a set of numbers to kind of help you out there. So it's either C or D. Go to page 422 of your textbook or rewatch Mr. Egler's video for the second part of that answer. Number 2, you can also find on page 422 of your textbook. It says, explain how to use the fundamental counting principle. So how we use the fundamental counting principle, I'm going to explain to you in my own words, and then you can figure out which one of these is explaining that in big idea language. So when an event M, the first event, has a lowercase m possible outcomes, and then there's a second event that has a certain number of outcomes, we can multiply the 2 possible outcomes together in order to figure out the number of possible outcomes of both events. All right, so the big important word there is multiply. All right. Number 3 says, describe 2 ways to find the total number of possible outcomes of spinning the spinner and rolling the number cube. So there's 2 different ways we could do this. The fundamental counting principle, which would say, okay, well, there's 1, 2, 3, 4, 5 here. So we have 5 times, there's 6 possibilities on that number cube. And I'll let you guys figure out what the 5 times 6 is. Or we could use a tree diagram, which would look like something like this. We would start with, let me erase that. We would start with the colors of the spinners. So we have green, we have orange, we have yellow, we have blue, and we have red. And from each of those, we could have a 1, a 2, a 3, a 4, a 5, or a 6 on the number cube, and you would do that for each of them to find the total number of possible outcomes. This is called a tree diagram. Number 5, the lock is numbered from 0 to 49. Each combination uses 3 numbers in a right, left, right pattern. Find the total number of possible combinations for a lock. So there's 3 numbers in this lock. I think that the easiest way to figure this out is the fundamental counting principle. So what we're going to do is we're going to multiply these 3 numbers together. The first number can be anything from 0 to 49. If we include 0 and 49, that means there's 50 possibilities for the first one. There's 50 possibilities for the second one, and 50 possibilities for the third one. So if you plug in 50 times 50 times 50 into your calculator, that will give you this answer here. Number 6, use a tree diagram to find the sample space and the total number of possible outcomes. So you can see there's a table here that talks about a birthday party. So the birthday party event could be miniature golf, it could be laser tag, or it could be roller skating. And then the time could either be at 1 o'clock or at 6 o'clock. So how we're going to do this is in red should be all of the events. So each of the 3 events should be listed in red. And then from that event, there should be each event should have 2 times listed in blue. Both times should be possibilities for each event. And then what you would do is count the number of blue possibilities and see if this matches the number that you get over here. Same thing here, like does this match the number of possibilities over here? If it does, then that one's your answer. Number 7, use a tree diagram to find the sample space and total number of possible outcomes. So this is asking you to do the same thing. We have a mascot that could either be a lion, a bear, a hawk, or a dragon. And it could either be realistic looking or a cartoon. So you're going to start with the type in red. So the 4 types should be in red. And then the styles, each type should have both styles listed from it. Count the number of blue options that are there, and that'll give you your answer. Number 8, use the fundamental counting principle to find the total number of possible outcomes. So the fundamental counting principle means we're going to multiply. So we're going to multiply the possible sizes. Well, there's 3 possible sizes, small, medium, or large. And we're going to multiply that by, well, root beer is 1, Coca-Cola is 2, Diet Cola is 3, iced tea is 4, lemonade is 5, water is 6, and coffee is 7. So we're going to multiply 3 times 7, and that goes here. Number 9 says use the fundamental counting principle to find the total number of outcomes. You're going to do the same thing. Multiply the possible numbers of memory times the possible number of colors. Same thing for number 10 and number 11. The only difference with 10 and 11 is now you're multiplying 3 numbers together instead of 2. So for this one, it would be, let's see, well, we could have a dotted suit, a striped suit, or a checkerboard suit. So that's 3 possible suits. You could have a one-colored wig or a multicolored wig. And then you could have balloon animals, juggling, unicycle, or a magic. So that would be 4. So if you do 3 times 2 times 4, that will give you your answer. You'll do number 11 in the same way. Number 12 says a store sells 3 types of note cards. There are 3 sizes of each type. Select 2 ways to find the total number of note cards that the store sells. So we could either do a tree diagram or the fundamental counting principle. So you should have 2 correct answers here. Oh, sorry, that does not look pretty. So 2 correct answers. One will be a tree diagram and the other will be a fundamental counting principle. So using that there's 3 types, you're going to list those first. Then off of each of those 3 types, there's 3 sizes. That should be branched off of there. And then you would count the blues to get your final answer. Fundamental counting principle, you're going to multiply the number of types by the multiply the number of types by the number of sizes, and that will give you the number of possible outcomes. Oh, I'm sorry, guys. All right. Number 13 says a true-false quiz has 5 questions. Describe and correct the error in using the fundamental counting principle to find the total number of ways that you can answer the quiz. So if there's 5 questions and each question can either be true or false, which means that there's 2 possibilities. Think about how you can do that. Remember earlier I said that multiplying is super important with the fundamental counting principle. So what did this student do wrong? Think about this word over here and what this student did wrong, and then correct their mistake. Number 14, you randomly choose one of the marbles. Without replacing the first marble, you choose a second marble. Name 2 ways you can find the total number of possible outcomes. So the same 2 ways we've been talking about this whole time, what are those 2 things we've been talking about? And then part B says find the total number of possible outcomes. You could use either one. I like using the fundamental counting principle, but I will show you how to use both ways. So if we use the fundamental counting principle, we're going to show that we're going to multiply 2 numbers together for our first pick and then our second pick. So the first pick could be any of the 4 marbles. And then the second time, there's 3 options. So you would multiply those together in order to figure out your answer. That's one way to do it. The other way to do it would be to make a tree diagram. So I will also show you how to do that. Both ways will get you the same answer. So for this question, it doesn't tell you which one you have to do, so you can choose. So if I were to make a tree diagram, we have green, we have red, we have blue, and we have yellow. If you pick green first, your second choice could either be red, blue, or yellow. Once you've picked the green marble, you cannot pick it again because it says without replacing it. So that's why there's only 3 options for the second marble that you pick. If you pick the red one, you could either pick the green one second, the blue one second, or the yellow one second. If you pick the blue one first, you could either pick the green one second, the red one second, or the yellow one second. And if you pick the yellow first, you could either pick green, red, or blue second. Then how we figure out the number of possible outcomes is we count these up. So it would be 1, 2, 3, 4, 5, 6. Keep on counting, and that will give you your answer that goes here. It should be the same answer you got from this method. Number 31. This last one is a review question from previous units. I'll still go over it, but just so you know, this is a review question that you should know the answer to. Name 2 pairs of adjacent angles and 2 pairs of vertical angles. So remember that adjacent and vertical, adjacent means they're next to each other and they share a line. Vertical means they are across from each other. So think about these angles. Which one's adjacent means they're next to each other and share. Vertical means they're across. So I'll show you an example. I'm going to label these 1, 2, 3, and 4. In my example over here, 1 and 2 are adjacent, 2 and 3 are adjacent, or 3 and 4 are adjacent, or 1 and 4 are adjacent. Vertical angles in my example would be 2 and 4, or 1 and 3. Hopefully you can use this example over here to help you figure out the answer to this question. I hope this video was helpful. If you need more help, you can email or message me on Teams, or you can email or message Mr. Egler as well.